Hey guys, and welcome to this lesson all about something called scientific notation. So here's the deal. Sometimes in the course of our studies, whether it's math or science or what have you, we encounter very large numbers and very small numbers. Now in this context, what do I mean by a very large number? In this case, I mean something like the weight of the sun, a number in which you have a couple of non-zero numbers followed by a whole bunch of zeros. I mean, the sun is pretty heavy. Or by a very small number, I mean something along the lines of 0.00000000000000000003818. So you get the sense of what I mean by a very large or a very small number in this instance. And I hope we can agree that both of these are pretty inconvenient to write. And imagine doing a problem in which we need to write these numbers again and again. That would be, well, pretty inconvenient. And so when we're dealing with these types of numbers, very large numbers and very small numbers that would be inconvenient to write and heck would take up like half our page, we sometimes turn to scientific notation, which is just a different way of writing these numbers that will be easier to work with and might help kind of uncover some of the relationships between the numbers. So here's the deal. I'm going to kind of show you a couple examples of scientific notation, and then I'll show you how we use it. Okay, so first things first, the weight of the sun, here it is. I can't even dream of saying what this number is, quadrillion, quintillion, septillion, who even knows? And what we call this is we'd call this the standard notation for the number, the normal numbers that we've been working with. And I'm just going to show you how we write this number using scientific notation. So we would write this number as 1.989 multiplied by 10 to the 30th power. And of course, we're talking about the weight of the sun, which is in kilograms in this case. So here is the weight of the sun written in standard notation. Here is the weight of the sun written in scientific notation. Let's think about the weight of one atom of sodium. Pretty small thing, pretty small weight. Here is that weight in standard notation. Whew, pretty tough to write out. In scientific notation, we would write this as 3.818 times 10 to the negative 26th. Of course, we're still working in kilograms. So maybe you get a sense just from these two examples of what's kind of going on with scientific notation. The way I described these before are we're talking about numbers where you got a couple of non-zero numbers and a whole lot of zeros. A couple of non-zero numbers and a whole lot of zeros, whether we're talking about a very large or a very small number. And so here's the general form of how we write numbers in scientific notation. So the general form is you're going to have a number multiplied by 10 to the something, right? And this something is going to be an integer, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. -1, -2, -3 if we're dealing with very small numbers. Remember that 10 to the negative 26th, if you don't recall, that means 1 over 10 to the 26th power. So remember, this is a very, very small number, and hence it makes sense in the context of writing out a very small number in scientific notation. Of course, 10 to the 30th power, a very large number, hence why it makes sense in the context of writing this in scientific notation. One key thing about this form of writing a number in scientific notation, this right here, this number has to be between 1 and 10. So that's really big. So in both of these examples that we've done so far, right, here's the number between 1 and 10, here's the number between 1 and 10. There's nothing wrong with writing a number that's not between 1 and 10, it just wouldn't be scientific notation. So let's do a few examples to kind of get the hang of it, and then you can try some as well. All right, so let's take a look at our first number, which I believe is kind of, what would you call this? One, so we got million, billion, trillion, 1,090 billion. Okay, so actually I do know how to say that number. Woohoo! Okay, so how would we write this in scientific notation? I'm going to take a moment to actually first write this as 1.09. Remember, we're looking for a number between 1 and 10. This is 1.09 times, well, a trillion, right? I might almost call this 1.09 trillion. And a trillion is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have 1.09 trillion, 1.09 times a trillion. Note to self, 1 trillion, this is 10 to the 12th power. And one kind of handy-dandy little tip here is that whenever you have a number like this, 1 followed by a whole bunch of zeros, the number of zeros will be equivalent to the power that we raised 10 to get this. So 1 followed by 12 zeros, 1 trillion, is 10 to the 12th power. So that means that we can write that original number as 1.09 times 10 to the 12th power, and that is how we would write it in scientific notation. So here is the standard form of the number. Here is the scientific notation. And so this is one way I really like finding out how to write a number in scientific notation. Kind of write it out as some number between 1 and 10 times, well, kind of using intuition in this case, times some power of 10. And then use that to then transition into scientific notation. I will let you in on a little trick too. Imagine our original number here, 1.09 trillion. And in theory, our decimal point is right there. And my claim is to take this number and transform it into a number that's between 1 and 10. I'm going to take this decimal point and I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces to the left. Right, and that's going to yield us 1.09, right? This is now a number that's between 1 and 10, and, well, that tells us that in scientific notation, we would write this as 1.09 times 10 to the 12th. So a little trick, I really like to use this intuitive method more, but a little trick in case you'd like to use it. So let's do one more together, and then I'll have you try this one on your own. So here we've got a number, I actually know how to say it. This is 23 million, okay? So let's first write this as 2.3 times, well, I think 10 million, right? 2.3 times 10 million would give you 23 million. So 10 million, 10 million. We know that this number right here has 7 zeros on it. We know that this is 10 to the 7th power. So in scientific notation, 23 million would be written as 2.3 times 10 to the 7th power. Boom. We've got it in scientific notation. Once again, if you wanted to use that trick, here's the decimal place to begin. We move it 1, 2, 3, 4, 5, 6, 7 places to the left in order to come up with a number that's between 1 and 10. Boom. That 7 places to the left tells us that we'd be multiplying 2.3 times 10 to the 7th. All right, let's have you give this one a try on your own. Pause the video, give it a try, then play the video. All right, in this case, I don't really know how to say this number. I do know that we'll write this as 4.029 times 10 to the something power. What is that power? Well, how far do we have to move this decimal place? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 places to the left, 10 to the 17th power. This is how you'd write it in scientific notation. So I hope we're getting a hang of how to take these numbers in standard notation and write them in scientific notation. Of course, all we've dealt with so far are just very large numbers. So time to start dealing with very small numbers. Going to be very, very similar, but not exactly the same. So check it out. First things first, I like to write this as 5 times some power of 10. Well, I think this is 5 times 0.000000001. So that was 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. Now, we got to be careful. We got to be really careful here. It's easy to fall into the trap of, counting zeros and assuming that that means what power of 10 we're going to deal with. Note to self, 10 to the negative first power, 1 over 10 is just 0.1. 10 to the negative second power, 1 over 100, 0.01. 10 to the negative third power, 1,000th, 1 over 1,000, 0.001. So we're going to be really careful about the temptation to count zeros and have that equate to the negative power we're going to raise 10 to. So you got to be really careful here, right? Because of course the number of zeros here is not equivalent to the negative power we're raising 10 to. So in this case right here, this number, although there are 9 zeros, this is actually 10 to the negative 10th power. Oops, excuse me, negative 10th power. So our final scientific notation is going to be 5 times 10 to the negative 10th power. And similar to that little trick that we had before, check this out. If we take our decimal place in this case and we move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the right in order to make this number now between 1 and 10. Right now we've got the number 5. Well, that number of decimal places we move to the right, that tells you the negative power of 10 we'll have to multiply by. Okay, Let's do another one. So in this case, we're going to know that this is going to end up being 4.01 times 10 to the something power. What is that something power going to be? Well, 1, 2, 3, 4, 5, 6. The negative sixth power in this case. Right, of course, 10 to the negative 6, very small number, so that makes sense when we're thinking about writing this in scientific notation. Okay, last one. Why don't you pause the video and why don't you try writing this number in scientific notation? Okay, so right off the bat, we know this is going to be 2.05 multiplied by 10 to the something power. What is that something power? How far are we moving this decimal place? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places to the right. 10 to the negative 11th power. Always want to make sure that we don't mess up our negative and positive powers. Of course, this is a very small number, so we're going to be raising 10 to a negative power. Okay, woohoo! So now we've learned how to take numbers in standard notation and transform them into scientific notation. Okay, well, time to take numbers in scientific notation and transform them into standard notation, which I think is actually a lot easier. Okay, so for our first example, we've got 2.3 times 10 to the ninth power, a nice number in scientific notation. So let's see, this is 2.3 times, well, what is 10 to the ninth power? That is going to be a 1 with 9 zeros, also known as, what, a billion? So 1, 2, 3, 4, 5, 6, 7, 8, 9. And perhaps you recall from a previous math class that when you multiply any number by some power of 10, your little trick for how to do that, well, we know the product is going to be 2.3 billion in this case. Or I guess, is it million? No, it's billion. 2.3 billion. And actually, we can actually just go ahead and write that. So 2.3 billion is 2,300,000,000. Note to self also, though, perhaps you remember from a previous math class that when you multiply a number by a power of 10, that just means take this decimal and move it to the right by 9 places, right? Our number is going to get a lot bigger. It's going to be getting bigger by a power of 10. Take that decimal and move it to the right 9 places. So there's 1 place. Of course, we're going to have 8 more. So it's going to be 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. Let's go ahead and get rid of the decimal place and that pink stuff. Add in our zeros. Does this agree with what we had before? Oh, look at that. Exact same number. So I always like us to have this intuition in the back of our heads, but never hurts to have that little trick on our hands as well. So not surprisingly, if I've got 9.901 times 10 to the 7th, well, multiplying this number by this power of 10 means take that decimal, move it to the right, 1, 2, 3, 4, 5, 6, 7 places. So there are 4 more places to go here. 1, 2, 3, 4. Let's get rid of everything. Let's place our commas appropriately. Let's see, 99,010,000. Boom, nailed it. All right, with that in mind, why don't you try question number C on your own. All right, similar to before, we're multiplying 6.23 by a very large number, some power of 10. It means we are going to be moving this decimal place to the right 15 spaces. Here's 1, 2, meaning we've got 13 left there. Holy cow, that's a lot of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yowza. Note to self, oops, excuse me. Note to self, I always put the commas in last because I kind of never know where they're going to be until I've got all my zeros down there. All right, whatever number that is, however you say that, kind of in standard notation, that is the equivalent of 6.23 times 10 to the 15th. Okay, we did a whole bunch of big numbers. Let's do 3 small numbers quickly. All right, 5.4 times 10 to the negative 7th. I'm going to use a little intuition first. So we got 5.4 times, well, 10 to the negative 7th power is 0.123456. Boom. Okay, so this number right here is 10 to the negative 7th power. So I think if we multiply that by 5.4, we'd end up with 0.123456 again, right? The same 6 zeros, 54. So here is our number in standard form. But I do want to note that, of course, just like before, multiplying 5.4 times 10 to the negative 7th power means we're going to take this decimal place and move it 1, 2, 3, 4, 5, 6, 7 spaces to the left. Here's 1, meaning there are going to be 6 more. So let's put in 1, 2, 3, 4, 5, 6 zeros. I like to throw a 0 out in front of the decimal place for good measure. All right, are these the exact same numbers? Oops, excuse me. I think that they are. So just want to go and show you that this is also a trick you can use here. All right, 2 more, and then we're out of here. All right, 3.002 times 10 to the negative 10th. Well, here is 3.002. We know this number is going to get a lot smaller because we're multiplying it by a very small number. How much smaller? Let's take this decimal place and move it to the left 10 spaces. So 1 space, 9 more. So 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is a small number. Oops, excuse me. Oop. Boom. There's your number in standard form. Very small number. All right. Last one coming up here. Let's have you pause the video, have you give this one a try on your own. All right, so you are welcome to use the decimal strategy. You're also welcome to recognize that 10 to the negative 9th power is 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you're going to multiply that by 7, well, boom, there you go, which is also the exact same thing that you get if you start with your decimal place after 7 and move it 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces to the left. So, woo, there's your introduction to scientific notation, kind of going back and forth between scientific notation and standard notation. So I hope you found it helpful, and I hope you enjoyed.